In the past few decades, our spacecraft have visited many exotic locations in the solar system, including icy comets that have orbited the Sun since the planets were still taking shape. We have explored relatively tiny asteroids, ancient rubble piles held together by weak gravity. And we have found that the largest asteroids resemble the building blocks of planets themselves, all of which suggests that these objects offer clues to how the planets formed. And we have even found evidence for a violent rearrangement of the planets. Computer simulations allow us to reconstruct the formation of our solar system 4.6 billion years ago. We use the laws of physics to create these virtual experiments in order to figure out how planets took shape. After the Sun ignited, most of the material around it had flattened into a disk of gas and dust. We can zoom into a simulation of a portion of the thin disk, a small piece of the universe in a box. Here, a dense swarm of objects clump together to form what astronomers call planetesimals. This simulation addresses how planetesimals form from much, much smaller particles, the size of pebbles. Pulled together by gravity, some planetesimals formed the planets, while others became asteroids and comets and dwarf planets. As the planets accreted, they carved out gaps in the disk, but the solar system remained quite cluttered. If we look at the orbits of the planets and accelerate the passage of time, so 1 million years pass by every 10 seconds, we can watch how the debris cleared. In this simulation, the giant planets, Jupiter, Saturn, Uranus, and Neptune, shift their orbits, and many unlucky asteroids and comets and dwarf planets get kicked out of the solar system. The migrating giants wreak gravitational havoc. The distribution starts out quite flat, but as most small objects get tossed out, others settle into stable orbits that allow them to coexist safely with the planets. But their orbits aren't as flat as the original solar system. Instead, they follow trajectories far above and below the plane of the planet's orbits. Today, the orbits of Pluto and other Kuiper Belt objects show exactly this pattern. The tiny icy worlds that inhabit the outer reaches of the solar system provide evidence for an ancient interplanetary transformation.